So to solve this problem, again, we obtain the base matrix. Now, a base matrix will be a configuration of the box that satisfies the length and the width of the box. So for a length of 9 centimeters to be occupied by box of width 1, 3, and 4 centimeters, we could have this configuration. 1 4-cm wide ball, 1 3-cm wide ball, and 2 1-cm wide ball. So this is the only configuration that can satisfy the length of the box. Because the base matrix must comprise all of the box required to fill up the box, and must satisfy the base area of the box. So the configuration is not based on the order of arrangement. Rather, it is dependent on the number of each of the balls that makes up the matrix. So this is the configuration that can occupy the length of 9 centimeters. Now, to complete the base matrix, we also have to occupy the width and the other length of the matrix. So, to achieve that, we will need 4 1-cm wide balls. On the line of the 4-cm wide ball, then we will need 2 sets of 3-cm wide balls on the line of the 3-cm wide ball, and then we would need first 2 sets of 1-cm wide ball and additional 2 sets of 1-cm wide ball. So this satisfies the base area of the box in the sense that we have a combined length of 9 cm, 432 on one side. Here we have 9 1-cm wide ball, which also satisfies the length of the base area. And then we have a width of 5 cm, 4 plus 1. And here we also have a width of 5 cm, that's 5 1-cm wide ball. Now the base matrix is also satisfied across 4 and 5 1-cm wide ball. That gives us a length of 9 centimeters. So you see that the arrangement of the box satisfies the base area of the box, which is a length of 9 and a width of 5 centimeters. So having obtained the base matrix, and in this case the only base matrix possible, we can go ahead to calculate how many of each of the balls in the matrix can fill up the box. But we cannot do that until we have obtained the limiting HCM for the solution. So again, we know that the limiting HCM is the biggest whole number divisible by the width of all the balls in the matrix, but not greater than the available height. So the available height is 13 centimeters, and this is not divisible by all of the balls in the matrix. Therefore, the limiting HCM for this solution would be 12 centimeters. So this is the biggest whole number that is divisible by the balls of 1, 3, and 4 centimeters respectively, but not greater than the available height of 13 centimeters. So the base matrix would be 1 into 4, that is 1 4-cm wide ball, 1 into 3, that's 1 3-cm wide ball, and 2, 4, 6, 8, 10, 12, 13, 16, 18, 20, 20 into 1, that is 20 1cm white ball. So this is a different way of expressing the base matrix. Pictorially, the base matrix is presented in this form, but in calculation, the base matrix could be written thus: 4 into 1, 3 into 1, and 1 into 20. Okay, that's 1 4cm white ball, 1 3cm white ball, and 20 1cm white ball. Okay, so we can go ahead and calculate how many of each of the balls would fill up the box to the height of the limiting HCM, which is a height of 12 centimeters. So it will be 12 times 1 over 4, 12 times 1 over 3, and 12 times 20 over 1. So that would give us a total of 3 4cm white ball, 4 3cm white ball, and 240 1cm white ball. So this is the number of each of the balls that would fill up the box to a height of 12 centimeters on this base matrix, that is 4 into 1, 3 into 1, and 1 into 20. Now, because the height of the box is 13 centimeters, there will be an unoccupied space of 1 cm. Therefore, to fill up the box, we would require a suitable non-base matrix that can occupy a height of 1 centimeter and satisfy the base area of the box. So the only ball that can occupy that height is the 1 cm white ball. Therefore, the number of 1 cm white ball that will occupy a height of 1 cm for a box of base area 9 by 5 would be 9 divided by 1, which is the height, multiplied by 5. So that will give us 45 1 cm white ball. So in total, to fill up the box, we will require 3 4cm white ball, 4 3cm white ball, and 240 plus 45, that is 285 1 cm white ball. So this problem is resolved on the base matrix and a suitable non-base matrix. So again, we see that in some cases where there are multiple base matrices, there will be a preferred base matrix. But where only one base matrix is possible, as in this case, we'll resolve it on that base matrix. And then the remainder height, which cannot be resolved on the base matrix, can be resolved as a non-base matrix. In this case, we have 3 4cm white ball, 4 3cm white ball, and 285 1 cm white ball. So this gives a total of 292 balls. In the composition of 3 4cm white ball, 4 3cm white ball, and 285 1 cm white ball. So that is the number of each of the balls that would fill up the box of dimension 9 by 5 by 13 centimeters.